We are going to do more factoring today since our whole chapter is factoring. We're going to be using a lot of ideas that we've already been using. So we're going to reinforce some ideas today, but we're also specifically going to talk about a shortcut that actually came up in the last chapter. So the shortcut got introduced when we were multiplying, but now we are going to reverse that shortcut. So the shortcut that we introduced in the last chapter that we're going to work with a little bit today is the shortcut that happens when you have two binomials with identical terms, but one is adding the terms and one is subtracting the terms. So if you zip through our FOIL, just remember how this works. So first times first is a squared. But then what happens with the outer and the inner? So the outer and the inner, you end up with outer, you end up with a negative a times b, and the inner, you end up with a positive a times b. And so those wipe each other out. So your final answer when you're done multiplying doesn't have a middle term because the two pieces of the middle term cancel each other out. So you just end up with basically the F and the L from your FOIL, the first and the last. So first times first is a squared and last times last. So the two last terms are b and then negative b. So a positive times a negative is a negative. So you end up subtracting b squared. So the reason why this is called the difference of squares is because both of these terms that you end up with are both square numbers and you're subtracting them. So what ends up happening is the terms in, if you want to go backwards with this, so we were multiplying this out to get this. What we're going to do today is we're going to be undoing that. So if we want to undo that pattern that we talked about in the last chapter, then we would basically look for two perfect squares, so two things that are being squared that I'm subtracting. And if that's the case, then I can undo those squares or square root them. And that gives me the terms in these original binomials that we were working with. So a simple example of that is our first example problem. So if we look, both of these are things that have been squared because h squared breaks down into h times h, and 64g squared breaks down into 8g times 8g. So those are both what we call perfect squares. They're things that we can square root and get a nice, easy to work with answer. So since that's the case, the things that we were originally multiplying there, the 8g and the h, those become the terms in the original problem we were multiplying. So that means that I'm going to have an 8g and an h in both of these. But the reason why I'm missing the middle term is because one of these I'm adding the two parts and the other one I'm subtracting the two parts. So it's reversing our multiplying pattern that got introduced in the last chapter. So recognizing the pattern, as it says right in your notes, recognizing this pattern can help you quickly factor. So if you see that pattern and you recognize it, you can basically jump from here straight to here without having to go through a long drawn out process. So it's kind of visual memory. So if you visually memorize that shortcut, then when you see it, you can just jump straight to your factored form. Now, there are a couple of twists that we're going to add in today. So I have to say, I miss watching your reactions in class when I would introduce twists or variations of problems. So I'll imagine your reaction right now. There's always a twist. And today we're going to introduce one. It's actually not too bad. It is really just kind of recycling some things that we've been doing. So the next example is going to get you thinking about the twist. So this is another problem where I've got two things and I'm subtracting. So if I have two terms and I'm subtracting and I'm trying to factor, I should automatically look and see, are those two things that have been squared? Because if they are, then I can use the difference of squares shortcut that we were just reviewing at the top of your notes. So in this case, that is happening here because y to the power of 4, I can break down into y squared times y squared. So it's basically y squared squared. And 625 is 25 times 25. So both of those are things that have been squared. So I can break that apart using the shortcut and say, okay, so the number before it was squared, those are the terms in my binomials. And one I'm adding, sorry, it's being a little bit glitchy. One I am adding and one I am subtracting. Now, here's the twist, and it actually is a tip that is at the bottom of your page. So I put it at the bottom as kind of a final reminder, but we're going to use it right now. So the tip at the bottom of your page, check your factors to see if they can be factored further. So we've got this y squared plus 25 and then y squared minus 25. Well, the y squared plus 25 we can't really do anything with, but this guy is following the difference of squares pattern, which means I can set the y squared plus 25 aside and just focus on that y squared minus 25 and pretend that that's a new problem. I can factor y squared minus 25. So I can take my factor and I can factor it more, because that's the difference of squares pattern again. I've got two things that are being squared. Y squared is y times y, and 25 is 5 times 5. So I can take that and I could break it down using that pattern again. So my factors are y plus 5 and y minus 5. So it's recognizing that shortcut. So I could take that part and break it down into that. And then the whole thing is still being multiplied by y squared plus 25. So that one I can't use the shortcut with because it's a plus 25. And in order for the shortcut to work, I have to be subtracting the two pieces, because the subtraction comes from the opposites that are happening when it's factored. So always check your factors and see if you can factor them even more. So in this case, we have a problem where we factored it, but we can keep going. So keep going until you can't go anymore. So in this case, our final answer, all the way factored as far as we could go, would actually be this. So we're going to look at one more problem, just to give you some reminders and some reinforcement of different things we've been talking about. So this is something that we already talked about. It got mentioned a lesson or two ago when we were talking about factoring. But one thing that I gave you a tip on, and this is a tip from a previous lesson, but it always applies when you're factoring, is before you try to factor anything, always check and see if there's a greatest common factor that you can pull out. Because if you can pull out a GCF, it makes the numbers smaller, the numbers that are left, smaller and easier to work with. So in this case, if you look at these numbers, 6, 30, 24, 120, so 30 and 24 and 120, those are all factors of 6. So there's a greatest common factor of 6 that I can pull out of this problem. And if I pull that out, it's going to give me smaller numbers, which are going to be easier to work with. So I'm going to go ahead and pull that greatest common factor out. So if I divide everything by 6, the first term turns into x powered of 3. The second term turns into 5x squared. The fourth term turns into a minus 4x. And then the last term, 120 divided by 6, turns into a, minus, not plus. We're subtracting it, a minus 20. So that gives me some much smaller numbers to work with. Now, this problem, because all of the different factoring strategies we've been using so far are fair game. So if you see our difference of squares shortcut, we can use that. If you see a quadratic trinomial, you can use one of our factoring strategies, leading coefficient of 1 or leading coefficient not 1 from the last couple of lessons. One of the other strategies we talked about was factoring by grouping. So if we have a longer problem like this would be a great factoring by grouping problem. So I'm going to kind of set that 6 aside, and we'll just remember that it's there when we're done. But I can make 2 different groups. This is a good factor by grouping problem. So the first group, I can pull out an x squared. So that's kind of the maximum amount of things I could pull out. So x to the power of 3 divided by x squared is x. 5x squared divided by x squared is 5. So that means I want to see if I can make the other group also have an x plus 5 when I'm left over, which I can. So right now you notice everything is negative in here. and I want this part to be positive when I'm done, so I can just pull out the negative with the greatest common factor. So basically divide by a negative greatest common factor, and it'll make everything go positive, so it will work. So not only do I want my greatest common factor to be negative so that I end up with positive leftovers, but 4x and 20 also have a 4 in common. So if I make my greatest common factor a -4, then when I divide both things by -4, it's going to make everything flip positive so that it matches the x plus 5 in the other part. Because remember, we want to make these two parts match. So -4x divided by -4, negative by negative is positive, that's going to leave me with x. -20 divided by -4, again, negative divided by negative is positive, is going to leave me with positive 5. So those parts match. So now we set our factor by grouping, we pull out that common part. So we're going to pull out the x plus 5 that they both have in common. And then what's left over from the first term is x squared and -4, and then don't forget that 6 is hanging out there, so we're going to put that 6 there. So always check for greatest common factor. You can use any of our different factoring strategies that we've been working with, so you have to kind of look at the problem and get a feel for what strategy is going to be the best strategy out of the different ones we've been doing. If you have more than 3 terms, then you're going to be looking at a factoring by grouping, which is what we just did. Now, let's go back to our tip. Check your factors and see if they can be factored further. 6 definitely can't. X plus 5, well, that's pretty simple. So that one, not really. X squared minus 4, that's difference of squares, because x squared can be broken down into x times x, and 4 can be broken down into 2 times 2. So that means we can use our shortcut from the top of the page to pull that apart. So that means that the numbers I originally multiplied were an x and a 2. One gets added, one gets subtracted. And then we've still got the x plus 5. We still got the 6. So this guy all factored out looks really long. That is our final answer completely broken down. So at this point, we are kind of starting to put together the different pieces that we've been using and the different tips and tricks that we've done. So always look for a greatest common factor. See if you can pull that out first. Look for this shortcut. Whenever you can use the shortcut, that helps. And then after you factor, look at each of your factors and see if any of those factors can be factored again to break it down even further. So always double check your work and see, can I keep going? You should keep going until you can't go anymore. And then it will be fully factored. So your problems that you're going to try today are going to be some problems that are similar to the practice problems that we did in your notes.